Probability is what we are considering today. Probability of an event happening can be expressed numerically as X, meaning X is the number of required outcome divided by total number of possible outcome. And the range of the probability starts from 0 to 1. That's why we have it 0 less than or equal to X, that's less than or equal to probability, X less than or equal to 1. So when the probability is 0, that means the event never occurred. But when the probability is 1, that means a perfect event. And we can also have the other side, which is where 1 minus X, 1 minus probability is the probability that an event not occurring. We want to consider now a question. The first example we are considering now is a box containing 40 oranges, 12 of which are alright. I picked one at random. What is the probability that it is A, unripe, B, ripe orange? A, probability of picking unripe orange with number of unripe orange, that's the required outcome, divided by the total number of oranges, that's the total possible outcome. Since we have 40 oranges and then 12 of them are ripe, so 12 over 40. So something will divide 4 will divide 12, 3, 4 will divide 40, 10. And you have to have 3 over 10, which is 0.3. Now, B, probability of picking an unripe orange. So the first thing you do is to know the number of unripe orange. And the total orange in the box is 40 minus 12, which is the unripe. So the number of ripe orange now is 24. And that will give us probability of picking a ripe orange would now be what number of ripe oranges divided by total number of oranges, which is 28 divided by 40. So 4 will divide 7, 4 divide 10, and that's 0.7. Another way is 1 minus the probability of unripe orange, which is 1 minus 0.3, and that will still give us 0.7. 2. A bag contains 10 white balls, 4 red balls, and 6 black balls. If a ball is selected at random, what is the probability that it is A, a white, B, a red, and C, a black ball in that order? So the first thing we are going to do is to find the total number of balls in the bag. And total number of balls in the bag will be 10 for the white, 4 red, and 6 black. Addition of 10 plus 4 plus 6 will give us 20 balls altogether because they are identical balls. So of the same size, which we have. So we now begin to pick each of those balls. So probability of picking or selecting or picking a white ball now is what? The number of possible outcome, which is the number of white balls, number of white balls, and the total number of balls involved. So that's 20. So that will give us 10 divided by 20. 10 divided by 20 is half, 0.5. Probability of selecting a red ball, that's the number of red balls, that's the one required. And the possible number is the total number of balls inside the bag. And that's, we have 4 red balls, 4 over 20, which is 1 over 5, and that will give us 0.2. C, probability of selecting a black ball with the number of black balls, that's the one required, over total number of balls, that's the number possible, and that's 6 black balls that are in the bag. So 6 over 20 will give us 3 over 10, which is 0.3. Now, to make our work simple, probability is a matter of chance and game. So we have a game. It's a game time. I want you to just take this game, you buy a playing card, and we have 52 playing cards with 2 jokers. So we now have it. The game says shovel a pack of 52, but that means we will have removed 2 jokers, 52 playing cards, and draw 1 card by chance. Note whether you have a heart, a spade, club, or diamond, and replace the card. Replace the card. Repeat the experiment 200 times. Copy and complete the table below. So if you pick a ball, you put a tally. Pick a spade, you put a tally. Pick a diamond, you put a tally. Pick a club, you put a tally until you have 200. So you can then add it to know the number of balls. But to make the work easy, I just wanted to show you so that you'll be able to differentiate between which one is a spade, which one is a club, which one is a diamond. So this is a card, a diamond card looks like this. Though you have its own number, you put its own number. A club will look like this. A spade is like this, and you have your art. So you have 52 cards with 2 jokers in a playing card. So that will help you to identify when you are picking it, when you have picked a diamond. It also help you to identify whether you have picked a club. It also help you to identify whether you have picked a spade. It will also help you to identify whether you have picked an art. So these are the way the cards will look like when you play card. The second game now is throw 2 die simultaneously 200 times after each other throw. Add the 2 numbers on the 2 die. Add the 2 numbers on the 2 die. Your total will be either 2. That's you have 1 and 1, 3, 2 and 1, 4, 2 and 2, 5, 2 and 3, 6, 3 and 3, 7, 3 and 4, 8, 4 and 4, 9, 5 and 4, 10, 5 and 5, 11, 5 and 6, and 12, 6 and 6. So you see the number of times you have each of these numbers, then you have your tally, and then you make your table. Copy the table below, showing the number of times you obtain each total. That's another view for you. Then we'll go back to our probability now. Now we want to consider the outcome table and the tree diagram. Outcome table and tree diagram. You know, we have just talked about a coin, a die now. We are going to talk about a coin now and a die. A coin. The first question is a coin is tossed and a die is thrown. What is the probability of getting a tail and a head? Yes, in a coin, you have 2 faces, the head and the tail. The head and the tail. And in your die, you have numbers 1 to 6. So that's why you have it tabulated. So the horizontal is the head and tail. The vertical are the die, the number of the die. So you have first one, you would have what? Head and 1. So 1 head, 2 and head, 3 and head, 4 and head, 5 and head, 6 and head. And the second column was 1 and a tail, 2 a tail, 3 and a tail, 4 and a tail, 5 and a tail, 6 and so that will be the outcome. And that's what we call the outcome table. That will be the outcome of throwing a coin and a die. The probability now say, what's the probability of obtaining a tail and a perfect square? So the first question is, what are perfect square? Perfect square are numbers that can have a perfect square root. So 1 times 1, that's 1. So 1 is a perfect square. 2 times 2, that's 4. 4 so we have 2 possible outcomes. 1 and a tail and 2 and a tail. Out of the 12 outcomes, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 outcomes. And we have 1 and a tail, 4 and a tail to be a tail and a perfect square. So the probability of obtaining a tail and a perfect square will now be what? 2, which is number of outcomes with a tail and a perfect square, which are 2 over total number of outcomes possible, which is 12. So that's why we have 2 over 12, which is 1 over 6. That decimal fraction will now give us 0.167. Take another one, an outcome table. 2 fair die are thrown together once. Find the probability that the sum of the outcome is a total of 7. B, the same digits. C, 2 prime numbers. So we see now. So since you have 2 die having 6 faces, the first one horizontal die, then the other one will be written vertically, horizontally and vertically. So we can then begin to pick them. So when this you have 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Discover that I picked the vertical first before the horizontal. Then the second column, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. The third column, 2 and 1, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. The fourth column, 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6, 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6, then 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. When you see that, you discover that you are having 36 outcomes all together. 6 in each row, 6 in each column. So that makes 36. So we want to see now the total of 7. That means when you begin to add it up, which one is going to give us 7? The first one is 1 plus 6, 2 plus 5, 3 plus 4, 7, 4 plus 3, 7, 5 plus 2, 7, and 6 plus 1. So we have 1, 2, 3, 4, 5, 6 outcomes that will give us a total of 7. So the number of probability of getting a total of 7, we have number of outcomes with total 7, and that's 6, as we have counted, over total number of outcomes involved 36. So 1 over 36, and that gives us the second one says of getting the same digit. And if you see that, same digits, 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So you still see 1, 2, 3, 4, 5, 6. So same digit is also 6, and total number of outcomes involved 6. So still giving us that. The next question will say of getting 2 prime numbers. Let's go down. Let's go there and see 2 prime. So 2 and 2, 3 and 3, 5 and 5. So we have just 3 options, 3 outcomes. 2 and 2, 3 and 3, 5 and 5. So 3 outcomes getting 2 prime numbers. So the number of outcomes with 2 prime numbers is 3, and total number of outcomes is 36. So 3 here 1, 3 here 12, and that will give us 0.083. Now let's talk about the tree diagram. A coin is tossed thrice. What probability of getting A, 2 tail and 1 head, B, at least 1 tail? Yes, I said it earlier, a coin has 2 faces, a head and a tail. So we use H to represent the head and T to represent our tail. H to represent the head and T to represent our tail. So let's see the tree diagram now. Throwing the first coin, you have head and tail. The first coin, when it's being thrown, you have just 2 options, head and tail. By the time you throw the second coin, if the first one is an head, that's the first head that we have here now. The second coin can also give us 2 options, and that will give us head and an head and tail. If the first option was a tail, that's why you have T coming first, then the second option can be head, then it can be tail. So we have 4 outcomes now after throwing the second coin, which are head and head, head, tail, tail, head, tail, tail. By the time we are throwing the third coin, we are having head and head. That's why you have head and head first. The third coin can give us an head and this or a tail. If we are having head and tail, the third coin can give us a head and a tail. If we are having tail and head, that's why we are having that first. The third coin can give us head, it can all give us tail. If we are having tail first, the third one can give us a head or a tail. That means we are not going to be seeing these 4 options again. We are seeing these 4 outcomes, these 8 outcomes. These 4 outcomes will not be there. 8 outcomes. So we have it head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Now we are looking for probability of getting 2 tails and a head. 2 tail and a head. 2 tail and a head. The order is not mentioned. two tail, one, two tail, two tail, and head. The option is not giving the order. The arrangement, so we have one outcome, two outcome, three outcome, and that will give us number of outcome with two tail and one head will be 3 over total number of outcome, which is 8. So that's 3 over 8, which gives us 0.375. Now, at least one tail. We go back there to see our table. At least one tail. One tail. At least means more than one will also be counted. One tail, two tails now. One, two tails, two. So we have 1, 2, 3, 4, 5, 6, 7 options. At least 7 options now is getting at least one tail. And the number of outcomes with at least one tail over total number of possible outcomes now becomes 7 over 8, which is 0.875. So you take this as your classwork. 1, a bag containing 2 black balls, 4 red balls, and 6 green balls. If a ball is selected at random, what is the probability that it is A, a black, B, a red, C, a green, D, a yellow, and then E, not a black, So, see you next class. I am Adeyemi Alao. Subscribe to my YouTube channel, which you can find there, which is Mathematics Made Easy, bracket MNE, all the capital letter by Adeyemi Alao. Bye.